Hello everyone, my name is Rohit Singhal and we were discussing about the topic hydrocarbons. In the previous classes, I have briefly started about the alkenes, about the properties of alkenes, about the polarity, the solubility, their their state of matter, liquid, gas, solid. I have discussed about the van der Waals forces also. In this class, I will discuss about the some preparation methods and chemical properties of the alkenes. So, let us start with the preparation. Okay. First, we can synthesize them from the alkynes. Okay. If you remember the alkenes, we have synthesized them from the alkenes by the hydrogenation reaction. Same we have to do here. Okay. This R can be anything, this R can be hydrogen, this R can be any methyl group or ethyl group, anything it can be. Okay. I am just talking about the alkene. So, what we need, same thing, we need a hydrogenation reaction, it is a hydrogenation reaction. Similar thing I have discussed in the synthesis of alkanes also. What it will do, it will give a proton to both of that CH double bond CH R dash. We all know that it will not take place directly by adding the hydrogen. We need some catalyst, and this catalyst are palladium in presence of carbon, and this set of reagent H2 in presence of palladium and carbon, this is known as Lindlar's catalyst. Lindlar's catalyst. Okay. And then the one thing we also have to know about what will the geometry, it can be a cis or it can be trans now. So, Lindlar's catalyst will always gives cis alkenes. Okay. So, how this alkene will be? This alkene will be, the structure of alkene will be C double bond C, okay. So, a cis alkene will be synthesized by the reduction of alkynes in presence of H2 and palladium carbon, that is Lindlar's catalyst. Okay. So, we can all if okay, now the thing, now you must have to wondering if we have to prepare trans alkene. So, there is, so in that case the reagent, so the catalyst used is different. Again we are using this same alkene, we know we have to use hydrogen here, but the catalyst will be different. What the catalyst will be? It will be sodium in presence of liquid ammonia, and here in this case we will get trans alkanes. Trans, how it will they look like? C double bond C, in the hydrogens are trans to each other. This again, this R and R dash can be the hydrogens, these R and R dash can be hydrogens or can be any other methyl group, ethyl group or something. Okay. And this will give the trans alkene. Okay. And this combination of H2 in presence of sodium and liquid ammonia, this reaction is known as Birch reduction. Okay. So, alkynes we have discussed two procedures, one is to synthesize the cis alkenes, another is to by the trans alkenes. From the cis alkenes we have to use Lindlar's catalyst, and for trans alkenes we have to use Birch reduction procedure. Okay. So, this is for the alkyne, this is by the alkyne synthesis. Then the another synthetic method is from alkyl halides. Okay. From how alkyl halides we can do is, let us take an example of alkyl halide first. Okay. So, what we have taken an alkyl halide, okay, and this R and R dash again I am representing means any alkyl halide it can be. So, I have taken in general this X represents the alkyl halide, this X represent the halide, sorry, X is the halide, X can be chloride, bromide, iodide, anything. Okay. So, what we need to do is we need to remove this X and also we need to remove something from this carbon. This carbon has the hydrogen to remove. That means, one thing is for sure that we have to remove an HX molecule. Okay. So, what we do in that for case, we use alcoholic KOH, and we heat up the reaction. What happens in that case, this X is removed and this hydrogen is removed, and this X and hydrogen forms an HX and gives us the okay. So, this is how an this can be produced, alkene can be produced from the alkyl halide. Okay. So, the reactivity order means how the reactivity order for this reaction is governed by 2 or 3 steps. That 2 or 3 steps are okay, the governing steps or the reactivity order. Okay. What we can change to change the reactivity, enhance or decrease the reactivity, what are the governing factors? First one is halide. Okay. The iodides are more reactive than bromides than chloride. Why is it so that iodides are more reactive in the alkyl halides to form alkenes? Because the halide has to be removed, and we all know that the carbon iodide bond is weaker than CBr or CCl. That means the carbon iodide bond is weaker. So, what happen is the iodide will leave more easily from the alkyl halide to give the alkene. Similarly, the bromide will cleave more easily than chloride. That is why this is the reactivity order, that the iodide are more reactive to produce alkenes from the alkyl halides. Second, what we can have is the type of okay. So, for this case, tertiary alkyl halides more reactive than secondary okay. For example, what I am saying is okay. This is a primary alkyl halide, because means the halide means the to the carbon where halide has been attached is attached only to the one another carbon. In this case, the halide is attached to the carbon which has been attached to the 2 carbons, and in this case the halide has been attached to the carbon which has been attached by the 3 hydrogens. So, in this case what I am saying is that the tertiary will be more reactive than the secondary than the primary. Okay. The one thing is we need to take care of in this case that the carbon besides the halide carbon must contain a hydrogen. For example, there should be no such case that a carbon X. Okay, let us take it to the next page. Okay. In this case, we have a halide, but we do not have any hydrogens to the adjacent carbon. So, what we have? No adjacent hydrogen. So, if in this case we are using alcoholic KOH and we are heating it, it will not give an alkene, okay, because there is no adjacent hydrogen to cleave. So, there must be an adjacent hydrogen to give us the alkene moiety from the alkyl halide. Okay. So, that is from it. Okay. So, the next synthetic method we have is from vicinal dihalides. What are vicinal dihalides is? These are carbon carbon means the halides are present on the adjacent carbon. This kind of moiety is known as the vicinal halides. So, how we can synthesize an alkene from this? Let us see. Let us suppose there is a CH2. Okay, same case we will consider CH2. CH2. Let us consider 2 bond only. Br. What we have to use? We have to use zinc as the reactant, and what will we give? It will give an alkene, and we will take out both the bromines and form zinc Br2, zinc dibromide. Okay. So, that is how in using the zinc we can synthesize the alkenes in alkenes from the vicinal dihalides by forming the alkene and the zinc dibromide as the side product. This type of reaction is called, we are losing the halides. So, it will be called dehalogenation. Wherever what we were doing in the previous from the alkyl halides is we were removing one H and one X. So, it is D hydro for removal of hydrogen and halo for halogen. So, dehydro so this is a dehydrohalogenation reaction, whereas this is a dehalogenation reaction. The hydride is not going, it is just the removal of the 2 hydrogens that is giving us the alkene. Okay. Taking up to the next procedure. From alcohols. How we can do it from alcohols? Okay, let us see. Okay. This is an OH group. So, what it is called is a 2 carbon. So, it is known as ethanol. Okay. What does the alcohols do? By the heating of the reaction, by the heating alcohols in presence of concentrated H2SO4, it gives us the alkene and the water molecule. How is it so? The H2SO4, the concentrated H2SO4 is a dehydrating agent. Concentrated H2SO4 is a dehydrating agent. So, what it does is this concentrated H2SO4, as soon as alcohol moiety is heated and it gives us the water molecule, that water molecule is being absorbed by the concentrated H2SO4. So, what happens if the product, if the H2O the concentration will decrease, what will happen, that the equilibrium, that the reaction will shift toward the right hand direction due to the Le-Chatelier principle. So, the helps. So, the concentrated H2SO4, the uses of it helps to drive the reaction in forward reaction. As we have learned, due to the Le-Chatelier principle, if the product concentration is going to decrease, then the reaction will shift towards the product side. towards the forward side. So, this helps to derive the reaction and gives us the good yield of the alkenes. Okay. Now, what this reaction will be called? What is happening in this reaction is a removal of water. So, removal of water is known as dehydration. And dehydration reaction were in presence of acid. So, it can also be termed as acidic dehydrogenation reaction, dehydration, acidic dehydration reaction. Why acidic dehydration reaction? Because the dehydration is being taking place in presence of an acid, and acid we are using here is concentrated H2SO4. The purpose of using concentrated H2SO4 is it is an dehydrating agent, and what's its role is it will absorb the water molecule that is being produced as a side product in the reaction. That will help the reaction to proceed towards the forward reaction more and more due to the Le-Chatelier principle. Okay. So, these are the procedures by which we can synthesize the alkenes. 4 procedures I have discussed from alkynes. Alkynes 2 procedures are there from cis alkenes and trans alkenes. The another one is from the alkyl halides, where we can use the alcoholic KOH, and the reaction name is dehydrohalogenation. This you do not have to cram the reaction name, you just see the concept. D means the removal. If I am anywhere using the D, this D word means the removal. If I am using the hydro, means hydrogen. Halogen we know it's X. Okay. If I am using hydra, something related to hydra, it means water. Okay. So, reaction like hydration reaction means addition of water. Dehydration means removal of water. Halogenation means addition of halogen. Dehalogenation means removal of halogen. Hydrogenation, we have all done examples of this. Hydrogenation I have discussed for the alkenes to alkanes, alkynes to alkanes. Hydrogenation is the addition of hydrogen, and dehydrogenation is removal of hydrogen. Okay. I have also discussed about this, and there can be combination of this hydrogen halogen. There can be a dehydrohalogenation reaction. Dehydrohalogenation, that means removal of hydrogen and halide. There can be hydrohalogenation. Means the addition of HX. So, this we have to see in terms of this naming. Do not cram the names, just see how this naming actually make the sense. So, whatever D is just for the word removal. Okay. So, these are the procedures we have discussed about how to synthesize the alkenes. Now, let us discuss about some chemical properties. Physical properties I have already discussed in the previous class. So, now let us start with the while discussing any molecule chemical properties, few things should be kept in mind. So, in case of alkenes, I have discussed there are 2-3 important things. First, these are rich source of, okay, we can say electron rich species. Okay. These are electron rich species. These are loosely held and due to these are loosely held by the pi electrons, and due to these two properties, these are electron rich species, these are loosely held by the pi electron species. This is the reason this gives, or this gives the oxidation reactions. If any molecule is electron rich, it will tend to give the extra electron to someone which do not have the electrons. So, the electron rich species in science we call them as the nucleophile, and this nucleophile often reacts with the molecules which have the, which do not have the electrons, that means the electrophile. Electrophile on the other hand means a species which lacks the electron, or we can say electron deficient. Okay. So, these is the basic you can say structure before discussing about the chemical properties. These are the electron rich species, and that is why they are more tends towards the giving the reactions of something like oxidation reaction, or sorry addition reaction, mainly we can say gives addition reaction. Whereas in alkanes we have discussed about the substitution reactions. Alkanes also give substitution reactions, but under severe conditions. Mostly we will discuss about the addition reactions of the alkenes, that we will discuss in the later class. Thank you.